Hi everyone, my name is Samel, Ezeonyeka. Today I'm going to be speaking on the management of design, construction, installation and commissioning of high pressure gas connection to UK Power Reserve, now part of Semcorp Group, 40 megawatt power generation station in Derby. At the moment of this project, I was an assistant project manager for gas connections. However, I've just currently moved on to a new role. Prior to UK Power Reserve, my entire focus had been on electrics. Joining UK Power Reserve and taking up the full responsibility to manage all the gas connections around the country was quite challenging, as gas was a new area for me. However, I've had several successes in which this particular project for high pressure gas connection is one of it, and I'm very, very much excited to actually talk you through it. The agendas I'm going to be speaking on today, the project objectives, my roles and responsibility in this particular project, the challenges, unique challenges, I must say, and how I was able to actually overcome these challenges, and conclusions, and potential future optimization for the site. At UK Power Reserve makes use of reciprocating gas engines, which basically, in a simple term, is the gas expands in the engines, which allow the pistons to turn rotationally, which converts mechanical energy to electrical energy, basically transferring that power to the grid. For today, my project objectives for today is basically going to be, to provide gas at an appropriate volume, temperature, and pressure. At UK Power Reserve, as an assistant project manager for gas connection, I report directly to the head of connections. So basically, regardless of the fact that it says assistant project manager, I was fully responsible for the entire gas connections for the entire sites. For this particular project, I work closely with Cadence, National Grid Metering, CNG Services and Gas Uni, Future Utility Solutions, Future Metering Services. Basically, with Cadence, that's basically liaising with the design approval and the direct connection to Cadence LTS, which was at the maximum operating pressure of 38 bar. With CNG Services, basically managing the delivery of the pressure reduction station and also dropping that pressure to about 7 bar. With Future Utility Solutions, basically the delivery of the downstream pipe works. And then with Future Metering Services was, dropping the pressure from 7 bar to 250 to 60 millibar, which is used at the reciprocating engines. Moving up quickly. So basically, the pressure reduction flow is a maximum operating pressure from 38 bar down to 7 bar and down to 250, 260 millibar, which is required at the engine. At the onset of the project, UK Power Reserve secured a gas load capacity of 600 megawatt thermal, which has a potential capacity to generate approximately 200 megawatt of electricity to the grid. Now, just coming up to that, I must say something really, really clear here. For a high pressure gas connection, it was first of its kind for the business. It has never been done for UK Power Reserve. Now, for myself, I delivered medium pressure, which is a maximum of 2 bar, and intermediate pressure, maximum of 7 bar, for over 25, 26 sites around the country. So encountering a high pressure gas connection was the first time, and it came with unique challenges, which I'm going to be talking us through it today. The first encounter was temperature. Very unique. I'd never had an issue with temperature of the gas when they dropped the pressure from 7 bar. It's never been an issue. However, for most of us that are very much conversant with Joule Thomson effect, for every pressure reduction of a bar, there's a subsequent temperature reduction of 0.5 degrees Celsius. So for this particular project, at the inlet temperature of 38 bar, you're having an average temperature of 10 degrees Celsius. And then when it goes down to 7 bar, it drops down to minus 5 degrees Celsius. And then subsequently at 250 to 60 millibar, minus 10 degrees Celsius. Obviously, straight away, this is a high risk because I've got a downstream pipe works, which for the PE pipes, which has a range of between 0 degrees Celsius to 20 degrees Celsius. So that is a very key risk to the polyethylene pipes. Also, I've also got risks to the valves, which obviously affects the gas. There's obviously a risk of a gas pressure loss. Now, to be able to mitigate this temperature risk, what I did is basically advising the team, saying, we've got an inlet temperature of 38 bar and an average temperature of 10 degrees Celsius, incorporating a preheater module, which is the exact one I've got on site, which then increases the temperature of the gas to approximately 23.1 degrees Celsius. And then when we've got the subsequent temperature reduction to pressure reduction to 7 bar, we're having approximately 8.1 degrees Celsius on the downstream pipeworks, which is within the range of between 0 degrees to 20 degrees Celsius. And then further reduction to 250 to 60 millibar. Perfect, that risk was gone away. Now, however, that's not the only risk I actually experienced. There's also a further challenge with underground services. Basically, this particular site was at the onset, it was situated at the old Derwent power station. So maximum number of utilities was actually in, but unfortunately, those were not captured in the utility report. So hence my first risk to actually mitigate this risk was, I said, first, what we have to do is it does affect the proposed below ground PA pipe works, and also it does affect the below ground low voltage cable, which needs to power up the ultrasonic meters and the rest of the electronic devices. So this is just to give you a context to it. This is the original routes at the onset of the projects, having basically from node 15, if you can say this from behind, 15 to 25, I have approximately 90 meters of 350 millimeters HDPE pipes, and then down to 5 to 15, approximately 159 meters of 315 millimeters HD pipeworks. And then I've also got 270 meters of low voltage cable, which is going to share the same trench of the gas, but definitely allowing appropriate clearances as per NJOG regulations. So this was the concept from the beginning, which was passed down from the project delivery team, from the project development team. So looking at it, my first risk was down to the installing those utilities with the fact that most of the underground utilities were not captured. So I immediately instructed trial hosts to be carried out. But when trial hosts were carried out, the outcome says, oil feed cables were found 1.2 meters and 1.5 meters below the ground surface. But yeah, that's fine. With previous experiences I've had, I'm going to say, go for a directional drill. Why can't we have a directional drill done, going below those oil field cables? However, what was found out is there's a table water that is still below the 1.5 meters of the oil field cables. And also there are risk of, heating unidentified utilities below that. So straight away, I had to give the instruction, no. We're going to go for an above ground installation for both the PE pipes and the low voltage cable. So for the installation of the power supply, I'd said we're going to go install the gas pipe on steel and then basically install it above ground still. However, I've got issues with how to install the LV cable, because obviously if I have to go above ground installing that is going to increase the cost, because I'm going to be having, I basically have to install that on a cable tray, which increases the cost and it affects my budget. So what I was going to do was, why can't we actually install this over the gas pipe? But basic knowledge, why are you going to install an LV cable over a gas pipe? Well, obviously I went down to the regulations, and based on IGEM edition 3 clearances, it does say you need at least above 25 mm clearance between the electric cable and the gas pipe. For this particular project, I allowed 150 mm clearances. That's what it looks like. Moving up straight up, another challenge I experienced was underground structures. So basically, when the demolition was done at the site, we found that there were massive tree-number drainage chambers found, which does affect the gas pipe route. So obviously that's a high risk, because there's no way I'm going to be installing a PA pipe underground on what looks like that goes all through the ground. So what you're going to be having is, you try to excavate that, there's a risk which obviously loses the integrity of the road. It could entirely collapse. So that's a high health and safety risk. That's what it looks like. So to be able to do that, my solution and my mitigation was straight away reposition the gas reception kiosk by taking off about 90 meters of the PE pipeworks, and then taking about 60% of the high-density polyethylene gas pipe above ground still. Now, the first question might be, what of the additional cost by going above ground and steel pipe? So basically, what I've done is, by reducing the 90 meters of the pipe, offsetting that cost, into the additional cost that would have come in from the steel pipe above ground installation. That immediately keeps my budget still within what I want it to be. Lesson learned on this was by repositioning the gas skills, the integrity of the access road is not compromised. Quickly on that, avoid health and safety risks due to existing drainage chambers, which I've mentioned earlier, and the recovered costs, which I did mention, basically offsets the additional costs that would have come in from the above ground steel installation. However, that's not all the challenges. This is a very unique one with a lead time. Now, what I would say with this is, at UK Power Reserve, our delivery timescales are basically driven by capacity markets. So that means we have to deliver at the specific time, because as a business, what it does is it's a reserve to the grid. And based on the contract, you have to deliver the particular capacity required of you. At the onset of this project, I received a 24 months lead time to be able to deliver 600 megawatt of thermal, which is approximately 200 megawatt of electricity. 24 months was a so much long time. There was no way I would be able to have done that. However, my mitigation to this is what is required by capacity market is 40 megawatt of electricity, which is approximately 110 megawatt of thermal. So I said, let's deliver this project in phases. What we could do is do the phase one, which is an interim solution, to deliver 40 megawatt, and later on expand the sites. That means future-proofing what I'm going to be putting in to allow us to expand the site later on. So moving on that, that's what the pressure flow looks like. Connecting to the LTS pipeline, down to a twin stream ultrasonic metering and the filters and the metering, which is provided by National Grid Metering, and then going all down to the pressure reduction station, the heat exchangers and all of that, and then down to the sub-meterings, which is provided by Future Metering Solutions, and then down to the generators. That's exactly what I just put together in terms of the flow, which is an inlet of 38 bar, down to the pressure reduction, down to the preheater, which increases the temperature of the gas, and then down to making use of a Joule-Thomson valve, which then drops down to 7 bar, and then we're having 40 megawatt of electricity generated into the grid. To mitigate the risk of the lead time, so I've got 24 months, that hasn't still gone away regardless. So what I did was key strategies, which is key strategic decision I had to take, was instead of installing that as a permanent solution, I went in to hire a temporary containerized preheater from Netherlands, ensuring that it goes through all design approval stages, and that's what it looks like on site. So we've got the preheater module and the pressure reduction station. Secondly, I went up ahead of the supply chain to be able to get the key long lead items, like the filters, the valves, the ultrasonic meters, as soon as possible. And very key, I had to request, because the filters was a very big challenge getting it ahead of time. I had to say, is there any existing filter that can be recalibrated? Remember, it's a twin stream, so if I make use of a recalibrated filter, then on a later date, I can have that replaced, and that's exactly what I did. Having a recalibrated filter fit in place, which all passed, and that's a twin stream there, it all came in, and it met up my deadline, and on a later date, what I did was have the filters installed with no downtime. And then further on, accelerated on timelines. Basically, I must say, I delivered this project in 8 months, which is a third of its schedule, which is really brilliant. First of its kind for the business. But I didn't stop there. Just key lessons on that, just to give us an idea. Repositioning of the gas kiosk, the delivery of the project in phases. These are key things I had to do to get this project to where it is. The rental, the recalibration of the existing filter, and going ahead of the supply chain. But very much importantly, that's what it looks like. That's what it looks like with the pressure reduction station. But there's a future optimization for the site. Now, having that sort of pressure reduction station, for most of us that are very much conversant with when you drop a high pressure, making use of a Joule-Thomson valve, energy is lost. How can we recover that same energy? And that's making use of a Joule-Thomson valve. The key thing to that is making use of a heat recovery infrastructure, capturing the heat. For all engines, 2/3 of the heat is lost as waste. Recovering that heat back into and using it to compensate for the gas boiler, that drops in the operational expenditure for the life cycle of the project. And also bringing in a turbo expander. What a turbo expander does is when it does this pressure reduction, the energy is captured, and that can feed in as a parasitic load. This is very much at its inception stage. I wouldn't want to go much further into it, but this is what the future looks like, and it's also going to be first of its kind for UK Power Reserve. Thank you. Any questions?
Should we start down there?
Thanks very much. Some are very interesting, and well done on doing it in 8 months rather than 24.
Thank you.
The question for you of a personal one, in the sense that you said your focus was electricity before you took on the gas role.
Yeah.
What steps did you take to ensure that you were competent in the gas side as you took on that role? Because it's quite a big difference.
Yeah, I think what I'd say first is I'm a project manager. I'm not a technical person per se, but to be able to get me up to speed, to be able to level up myself in speaking to very high qualified technical people in industry was one, getting myself a member of IGEM. And what I did further to that was attending several professional development courses, which I started building up myself. For every course that comes in and I'm opportune to do that, I get into that, getting myself upskilled in the regulations, reading through all regulations required for me to be able to deliver my project and actually walk through these successes, which I've just mentioned is one of them.
Okay, thank you.
Thank you.
Very good. And so clearly the state of the site was a big issue, or the unknown. Did you not do a geophysical survey?
Definitely it was done.
Yeah.
Definitely was done.
That was clearly inconclusive then, was it?
No, it was done. Like I said, we had to do that, but you bear with me that up until you break ground properly, you never know what is below that, regardless of the geographical survey you do, but you still need to do a trial hole completely to be able to see what is physically on the ground. But yes, I hope I answered your question. Thank you.
I'm going to carry on with the question from earlier around competence, actually. You said as a project manager you went out and got yourself trained up.
Yeah.
Where did the technical expertise come from for this? And then actually as project manager, how did you go about verifying that what you were being told was correct?
Okay, that's a good question, actually. So, but basically, what I did personally, like I said, I'm a project manager, and what I do is basically to manage the timelines. And in terms of the technical due diligence, I've got a technical expert that basically checks what I do and the decisions I make. So the business has a technical expert that is well qualified, that sort of does a check on what decisions I'm taking. But what I did was that prompt decision on asking the right questions and sort of checking with the regulation, does this fit? When I do my reading, I pass it down to the technical expert to say, is this correct? Is this the right thing to do? So for this particular project, which is quite interesting, is actually taking an immediate decision. For instance, hiring of the containerized pressure reduction station and the preheater was a brilliant idea, because if we hadn't done that, there's no way we can meet up with that deadline. But it's asking the right questions. Where can we get that? It's a scenario whereby I'm being asked, let's do this, get this timeline, and I'm saying, how high can I jump? And that's where I go about searching around the world to see where can we actually get this done. And that's sort of where I fit in taking the right decision and having it checked with the right people. Thank you.
Thanks. Good.
Yeah. Is there anything you'd have done differently in hindsight?
Say that again, please.
Anything you would have done differently?
Would have done differently. I don't know what else I would have done in reducing 24 months to 8 months, but I can't really pick out anything rather than looking at the future optimization, which is much more of, if I'd known this, most of this would have been future-proofed to that future optimization. So yeah, if what I've done is just further read into it, if I'd known all of that, I probably would have gone much more in-depth on it, but obviously I wouldn't have had the time to deliver it. But from my own perspective, delivering the 24 months timeline to 8 months is brilliant. Thank you.
I think I've got time for one final question, Samuel.
Yeah.
What you seem to have encountered a lot of change on the project.
Yes.
Yeah. How did you personally manage that and communicate that with the people you were
with? So as a business, UK Power Reserve, we've got a change control process. So that goes through typical procedures in the business, all the lines up. So I report directly to my head of connections, who then report directly to the delivery director. So all these changes go through appropriate processes. However, I encountered very, 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 very unique challenges in terms of, for instance, going above ground still and the cost to be able to do that. To be able to break that, obviously, if I'd maintained the original gas route, it's impossible, because that's an additional cost, and that immediately brings in an exceptional report. So what I did was to be able to prove to my directors and my head of connections that taking away 90 meters of pipeworks, that cost immediately offsets in a way the entire cost of the route. So there's very minimal change in costs in difference of what I've got within my budget. So I still had that within my budget and delivered it through. So actual change process is in place, and then also being able to actually prove to them that it all still works. It doesn't take me off my budget. Thank you.